Hello, my wonderful math students. So I am so excited to present. I know that this week I can't see you live. I'm going to do some open office hours, but this week's lesson is going to be presented to you via video. So it's going to be super fun. And I know you're probably wondering, Miss Farmer, what in the world are you wearing? It's because this is one of my other favorite weeks of the year, and we are doing one-step equations. So I love equations. I love working with variables. I love solving the mystery of what a variable could be. So let's kind of review. In the past, I've given you a variable and I've given you things to substitute for it. This time, I am not going to tell you what the value of a variable is. Remember, a variable is a letter. So we are going to use our sleuthing skills, okay? And we're going to do this. So if we're ever finding a mystery, first thing I think of is Scooby-Doo. I am a 90s kid for sure. So if you don't know who Scooby-Doo is, um, I hope. If you don't know who Scooby-Doo is, this is a show that was in the 90s. It was about a gang of friends and the dog, which is named Scooby-Doo, and they solve mysteries together. And so my favorite character is Velma, who she's the super smart, socially awkward nerd, totally me. So I even got my Velma shirt on today. So I am channeling my inner Velma to help you learn how to do these one-step equations. This is so exciting. Okay, so the first vocabulary term you're going to need to know to help you is what is called an inverse operation. So an inverse operation is something that undoes the other. So for example, it's pretty common to use the word opposite operation, but they're not really the same thing because you don't want to just do the opposite, you want to undo it. So and I'll show you some examples, but the inverse operation of addition is subtraction. The inverse of subtraction is addition. They undo each other. Same thing with multiplication and division. They undo each other. So they are called inverse operations. So these are your notes. They're available in the announcements. I think my video is cutting off a section of the bottom, but it's fine. So when we are doing a one-step equation, we are going to use our inverse operations, and this is where I start thinking about Scooby-Doo. If I am trying to figure out what x is, I know that x plus 23 equals 90. Okay, so I have to kind of work backwards and use my notes. I gotta solve the mystery. So you know how it's kind of like you have to backtrack and find all the clues to figure this out? That is exactly how I think about it. So I think, okay, well, whatever that mystery number is, it added to 23 to make 90. So if I'm working backwards, I can undo addition with subtraction. So what if I subtracted 23 from that number? Now, this is a key. This is a beautiful equal sign, okay? An equal sign is super important because it means that things are equal on both sides. This is in that Desmos activity where we did wait for it. It is like a seesaw, okay? Both sides, whatever happens to one side has to happen to the other. So if I'm going to use the inverse operation of subtraction here and be like, all right, so what if I subtract 23 from 90? Will I get that mystery number? And I totally do. So you're just going to use an inverse operation. The two things you want to grab that they are super important is one, know your inverse operations, and two, you have to do it to both sides of the equal sign. Just like in these notes, I like to draw lines down the equal sign so I know that they stay even. It helps my brain. And I'm going to do some examples for you in this video. Okay, so let's do an example. Velma. All right, my first example is 16 equals b, which is my variable. I don't know what that is, plus 7. So we can go ahead and guess. I mean, we could plug in random numbers if we so choose to figure out what number plus 7 is 16. Or I can use my inverse operations and solve this in one step. I don't have to go guessing. Okay. So I do know what is currently happening is addition. So what can I do that would undo it? Like what can I do? And I know that that is subtraction. I know that subtraction would undo it. Okay? Now remember, this is your equal sign. Okay? Whatever happens on one side of the equal sign must happen to the other. So I have to subtract over here too. Okay? So I know I'm doing subtraction, but what am I subtracting? Well, I know I'm subtracting the 7 because I want to know what that variable is. So if I subtract 7 over here, I have to subtract 7 over here. This is not too bad, right? So now these are going to undo each other, so they end up canceling each other out. And then I'm just left with b, because 7 minus 7 is just 0. Now 16 minus 7 is 9. Let's see if that works. So if I take the number 9 and I plug it in for b, because we did, if you remember us doing substitution before break, it should come out as a true statement. So let's just check. So if I did 16 equals, instead of the letter B, I'm going to put 9. 9 plus 7. 16 equals 9 plus 7 is 16. If it comes out as a true statement, we did it right. Woohoo! So I know if it's asking what B is, B equals 9. I'll use my detective skills to figure that out. Okay, so that's how you would undo addition. I'm going to do each operation in this example, just so you know. So let's do subtraction. 22 equals C minus 4. 22 equals C minus 4. Okay, I don't know what minus 4 would equal 22, so I'm going to use my detective skills to figure this out. So I'm going to go ahead and just draw a line for my equal sign. We're just going to, so I know it, bring it down. I know that it's subtraction going on here. So what is the inverse operation of subtraction? Oh, addition. Cool. So I know I'm adding, but wait, an equal sign only works if you're doing the same thing to both sides. So let's add. Well, what am I adding? So I'm going to go ahead and add that 4 because I'm like, wait a second, whatever that number is, it's subtracted 4. So I'm going to undo it by adding 4 and see what we get. Okay. So then I'm just stuck with C because these end up canceling each other out. 22 plus 4 is 26. So before we have to make sure that that statement is true, okay? So I'm going to go ahead and try to plug in 26 where I see the letter C to see if that works. So 22 equals 26 minus 4. So 22 equals 26 minus 4 is 22. Hey, it works. So that's a true statement. I got it. Isn't this fun? Mystery. I got 2 more for you. What if it's multiplication? And I know this is multiplication because that's a coefficient and a variable smack up next to each other. So that is 4 times x. All right. So just like in the last examples, okay, some number times 4 equals 12. Now I know you guys are probably already doing this in your head. You already are pretty aware that what number times 4 is 12. But sometimes you get bigger numbers and you can't always do those in your head, so we have to make sure that we go backwards using our little detective skills. Okay? So we have to uncover it. So I know that it's being multiplied to 4 to get to 12. So I'm going to undo it. We're going to work backwards. How would I undo? So something times 4. So the inverse operation of multiplication is division. That's what would undo it. Okay. So let's divide. And we divide, you can either do divide by 4 or you can write it as a fraction bar. I'm going to write it as a fraction bar. So this is division. I'm going to divide by 4. Fraction bars just mean division. Okay? That's all it is. So this is 4 times x. I'm dividing by 4. And again, you can pause it and go back if you'd like to. Sorry. Okay, so we are going to divide. These are going to end up canceling each other out, and then I'm just left with my variable. 12 divided by 4 is 3. So let me go ahead and make sure that that's a true statement. Does x actually equal 3? So let's go ahead and try it over here. 12 equals 4. Instead of times x, I'm going to make it times 3. I'm substituting. 12 equals 4 times 3 is 12. So it's a true statement. We just did it. Okay, last one we're going to do is, what do you do if you have division? Woo! What do we do? So in this case, 5 equals some number that I don't know divided by 4. Huh. Okay. So in order to, I have to all right, I have to go backwards. I have to trace my steps, right? Little mystery. So I'm going to work backwards. So what would undo division? Oh, I know that. Multiplication. So I know I'm going to multiply both sides. Actually, I'm not going to write it as an x because that would be confusing because it's, yeah. So I'm going to multiply on both sides. We know those big dots mean multiplication. All right, so what am I multiplying though? Okay, so I'm gonna use my mystery skills. A number divided by 4 is 5. So if I'm dividing by 4, in order to undo it or trace our steps backwards, I'm gonna multiply by 4 to figure out this mystery. So divide by 4, multiply by 4, they're gonna end up canceling each other out. And I'm just left with my variable, which is what I want. 5 times 4 is 20. Okay, let's see if that's a true statement. Let's make sure that's right. 5 equals, instead of the x, I'm going to put a 20. I'm going to make sure I'm going to substitute. 20 divided by 4. 5 equals 20 divided by 4 is 5. Sweet. So I just used my mystery skills to solve this mysterious variable. So in this case, I want you to go ahead, please feel free to pause the video, rewind it, watch it again. It's one of these things where once you do it a couple times, you're like, oh, please, you have these wonderful notes that are available to you in the announcements. I am here. Again, I know I won't see you live every day, but you're going to be fine. We're going to have open office hours if you want to pop in. And then you want to go through and get that practice in Desmos. There's some practice fun activities in the OLS to start substituting. And then you do have a graded assignment in progress learning this week, okay? So I'm always here for you via email. I'm super proud of you, and I will see you soon.